Now in the same way we'll be doing the same expression for the basic buffer, right? We'll be saying that what is the buffer action in the case of the basic buffer, right? So basic buffer, first of all you should know it consists of weak base and it consists of salt, and salt is of weak base plus strong acid, right? So let us take an example for the weak base, that is suppose NH4OH, ammonium hydroxide, right? And the salt which I am taking into the consideration is suppose the same base from same base and strong acid, let it be HCl, so we get NH4Cl, right? So that means now the constituent of the basic buffer is this and this, right? That is the ammonium hydroxide and the ammonium chloride. Now what we get to see in the buffer, basic buffer, what is actually present in the solution? As it is a weak base, so obviously it gets partially dissociated and there is an ionic equilibrium existing between the ions and the unionized molecule, right? In the same case, this NH4Cl is an electrolyte, so obviously it will get decomposed into the ions. So these things are already present in the solution. Now how it is resisting the pH? So what I am doing, I am adding acid to it. We know that the acid release the hydrogen ions. So that means these hydrogen ions can alter the pH by changing the amount of hydrogen ion concentration. But actually they don't alter the pH. How? Because they get consumed due to the reserve acidity of the solution. Now what is that? Look at the board. So these hydrogen ions are actually consumed by these hydroxide ion released from NH4OH, and they get neutralized to form water. So that means these hydrogen ions are just consumed, right? So that means we are not left with the extra hydrogen ion that can alter the pH, right? Similar way, when we add base, it releases the hydroxide ion. So that means they can affect these hydroxide ion concentration just by increasing them and making the solution more basic. But actually they don't, because they also get neutralized or they also get consumed. So just look at the board, who consumes these hydroxide ions. So these hydroxide ions are actually consumed by the ammonium ion of the salt to form ammonium hydroxide. So that means again they are consumed. We are not left with any hydroxide ion that can alter the pH. Similarly, if I dilute this basic buffer, then also I get H and OH ion. So similar way, the H get neutralized and the OH is again neutralized by NH4, but this time this NH4 comes from the NH4OH. So that means these are getting just consumed and their concentrations are just increasing. That means according to Lee-Chartley principle, the forward reaction is just favored. So this is how, similarly as we done with the acidic buffer, it is totally same. The difference is that it is a basic buffer with a weak base and the salt of strong acid and weak base. And it was a strong acid plus salt of it was the weak acid plus salt of the weak acid plus strong base. The difference lies only in the weak acid or a base what they contain, otherwise they are similar in all aspects. The buffer action is similar, right, as you can see here. Now let us look for the pH again for this basic buffer. We know pH is equal to minus log hydronium ion concentration, right? You know that. Now what I am doing is I am just writing a general expression for it. Suppose this is a weak base, so it gets dissociated to form this, right? We have a salt which gets dissociated to form this, right? So I can write the expression ionization constant for the base. You know that how to write, we did in the equilibrium, right? B positive, that is the concentration of product divided by concentration of the reactant, right? So this is what I have. So if I want to know the concentration of OH, because we know that in water the at particular temperature concentration of H and OH are similar, so we can get the pH from either of, right? So that means I can have the concentration of these hydroxide ions. So just I am shuffling them up. So what do I get? I get this, right? Again, as we did for the acidic buffer, so what we were saying that it was the base. There it was acid, so here it is base. So I can write Kb concentration of base, and again this B positive will be equal to this Ba. So I can write salt in spite of Ba because the concentration is going to be same. So this is what I have. Now I am just substituting the value in the minus log expression. So what do I get? I get pH is equal to minus log Kb, concentration of base divided by concentration of salt, right? This is what I have. So solving again for it, I can write this equation as base upon salt, right? And we can also write in the either way by making them positive. So this is what we got the pH for the basic buffer. I think you understand in a better way because it is just similar to the acidic buffer which I told you, right? Now the question is that as you are now familiar with the buffer solutions, as you are familiar with everything, where are these buffer solutions are actually used, right? As I told you one example, that our blood which is flowing in a body, which is just absorbing the food and just getting distributed all over the body, is also a buffer, right? Because we do take acidic food, we do take alkaline food, but still the pH of the blood remains the same. So that means it has a use in a biological process, right? So the other use is that it is used in the industries, like for making paper and many more things, ink and all. We need the buffer solution, right? Similarly, in the case of metallurgy also we need the buffer solution. Similarly, it plays an important role in the agriculture branch as well, because we have to have a certain pH of the soil or the fertilizers which we use. So that means it plays an important role in the agriculture as well. So buffer solutions are actually a very important solution because they have a special property that they can resist the change in the pH when we add certain kind of substance to it, whether it is acid or a base, right? One more thing, we have buffer index. What is this buffer index actually? First of all, you should know it is denoted by beta, right? It is actually equal to number of acid or base what you add to the solution and accordingly what change in pH occurs. So this is the buffer index, right? Or we can write, if I add acid to it, so I can write the expression is like this also, that is acid to change in pH. What is this D specified? The small amount, like I added small amount of A and there is small amount of approximately constant amount, you can say the change in the pH, right? Similarly, if I have base, so I can replace it with the base. So this is the buffer index, and the important thing, buffer index always remain positive. It has a positive value always, right? So you need to remember that, and it is very important, this thing, the buffer solutions, and they play a very important part in, I told you, in an agriculture, industries, the biological process, and most of the, you can say, in the branches, they are playing an important role.